Hi everyone and welcome back to PyVista. Today we are going to go deeper in each single step of the machine learning pipeline, from the data collection with web scraping to the feature extraction with packages like PyVista for feature edge extraction and path extraction also using the Dijkstra algorithm and so on, to the fit training step, how to use TensorBoard and how it's working for the loss function, and also to understand how to deploy a system in AWS. We're going to go in overview all these things. So let's go ahead now with the presentation. So the first thing we need to understand together is the data collection step. We need to gather relevant dataset from various sources, including databases, APIs, or manual labeling. Perform data processing to clean, normalize, and format the data for analysis. So what is important and how to perform that? So if we go back to this slide and how to get this slide. So let's search to bottles. Let's say I want to build a dataset of only the bottles and train, for example, a classification on images to detect if it's a bottle or not, or depend, for example, the size of the bottles to be able to recognize the size of bottles or something like that. So if I want to perform this kind of algorithm, the first thing I need to do is to get the data. But problem is I don't have the images, so I need to do one thing which is called web scraping. What does it mean? Meaning to be able to extract, to download all the images, all the relevant images from the web. So how to do that? We need to first search on that, and then we have one key which is F12. You can click on that, and if F12, you can see that I have all the images here. When I go back, when I scroll down with the on this page, so I see all the images which is uploading in the web page, in the local storage of the web page, and then so it's we can determine from now that it will be easy to download this thing using get selector in every language we want to do. But then we'll be able to download the images, and the question is now, okay, I got the images, but how can I have the if I want my code to be able to recognize the size of the bottles, for example, how can I find this information? So maybe I make a label manually, or maybe I can also find this information in the source code, meaning let's see elements. And here we have the style, the CSS, the HTML and CSS code. And generally in the div function, in the body of the CSS, I can find also other information. So this is not the principal concept of this video, but you just need to have in mind that it's possible to extract information and to do web scraping using the HTML and CSS. And in the CSS and in the HTML functions, you will find, in fact, the keywords which allow you to download the relevant data with the relevant labels. So this is the first thing we need to do. Let's now come back to the presentation. After doing the data collection, we need to do the feature engineering. As we saw together last week, feature engineering can be identify relevant features or variables that capture important information for the task, extract, transform, or create new features to improve model performance. So in the last week, we saw for 3D point cloud that we can extract using the bounding box and other tools to extract relevant information. Today, let's observe the package of PyVista. So the PyVista package provide some built-in function for extract feature edges. What does it mean? Meaning we have at the beginning a mesh, okay, or a point cloud, and if you need to, for example, to convert a point cloud to a mesh, you can go to my other channel for the 3D computer vision, and over there you have all the information to convert point cloud to mesh, or mesh to point cloud, or mesh to voxels, and here, for example, if I have this object, okay, in 3D meshes, and we can identify and recognize here all the triangle meshes, and I want now to build a model which is be able to recognize which type of object is it. Do I need all the meshes, all the triangle meshes, or can I, or maybe it's enough to use the feature edges? So maybe it will be enough to get the feature edges, and then with this built-in function of PyVista, I can also get the feature edges in point cloud directly. Okay, so at the beginning you get that in mesh, and then you can convert it in point cloud. And the point cloud will be, in fact, all the red lines that you can see, it will be in point cloud. So then this information, which is much better because it's more relevant information to identify and to recognize which kind of object is it. So then we can use that. Okay? And this is, for example, another example of the Bunny datasets. From Open3D, we also worked with that at the beginning. And if you remember this kind of dataset, we have some holes. If we want to close these holes, we have several methods. We can use complete holes from also TreeMesh, and also you can use the feature extraction, the feature edges extraction, and then to try getting this area and to complete it with other methods. So for example, also in machine learning, you can use some methods of linear regression, or also to complete with a grid or with polynomial interpolation. We have several ones to complete this area, and then to add a mesh, the relevant mesh part in this area. So this feature edges extraction can be very significant for us and can help us in every project. We have also another examples of extracting features. Here we have a globe, okay, of the world, and we have now from this point to this one the Dijkstra algorithm to get the faster path from this point to this one in the mesh. So this is another examples. You can see here in the PyVista project, in the PyVista package, we have here the examples, and here we have all the options we can do. For example, this is for collision between two meshes, how to extract the area of the collision. You can also use sign distance field. This is the extract edges that I just showed to you. And that's it. Let's go ahead. Now, when you perform the feature engineering, the feature extraction, we need to select the best model as possible. In order to select the best model, we need to choose appropriate machine learning algorithm or model based on the problem requirements and dataset characteristics. Experiment with different models, hyperparameters, and techniques to find the best performing model. So now we have also several packages. We have, of course, the scikit-learn package for in fact all the machine learning models. And okay, so I wanted also to show you the different options we have in scikit-learn. So you can see here the ensemble learning method from scikit-learn. We have AdaBoost, bagging classifier, extra trees classifier, gradient boosting, random forest. We have also linear models such as logistic regression, rich classifier, SGD classifier. We have also here the naive bias, canary snare boards, the neural network. One remark, which is important to understand, that when we want to build a real neural network, it's always better to use a sign package for that, meaning PyTorch or TensorFlow are better package and are completely assigned to this task of building neural network and train them. So, for example, also PyTorch is completely adapted to train a model on GPU, TensorFlow also as well. So it's always better to use them, but you can also use scikit-learn for debugging, for example. We have also several options for the pre-processing. If you, for example, in the data you have names or you don't have only numbers, so you can also use label encoder or standard scaler for the normalization. We have also other models such as SVM for super vector machine, SVT super vector classifier, linear SVC, decision tree classifier, and we have also all the possible metrics that we need to have in the classification process. For example, the accuracies, precision, recall, F1 score, ROC, and confusion matrix. Now, I wanted also to share with you how the code needs to be organized. So the first thing we need to do in the code is to load the dataset, then to get the classifier. After that, we need to split our dataset to train, test, and validation sometimes. So here, I haven't mentioned that, but it's important to do so. And we need, so this is the reason why I haven't mentioned that, because in the train, we use the train with the k-fold cross validation. And so inside this process, we are going to split the train with train and validation. And the test will be kept in fact to the end, to the last validation, to the last evaluation. We have also now the prediction and all the evaluation method. So now you can see that what I did here, I used the data of last week. This was the data, okay, for this was the feature extracted from the point cloud to classify, to perform a binary classification, if it's a chair, yes or not. So I use different methods as you saw, and the results are currently that in the different methods, so linear logistic regression, rich classifier, SGD classifier, as we extract features from point cloud, but it's a very short, small data set, so don't take conclusion regarding the how benefit can be one model on specific point cloud. It's not, it's only to show you the organization that we need to have in this kind of project. Then after, so we saw now the model selection, we saw also the model training. So now let's just have a look on a slide to, so this is an example of TensorBoard. What is important here is the different losses, okay? When we build a neural network on a specific project, it's completely normal to have several losses. Okay, we can have the loss of reconstruction, the loss of MSC, the other losses, and so we need to make sure that all the losses are we need to make sure that the loss decrease during the epochs, during all the epochs. So this is the goal of checking in real time the TensorBoard. We can also, if it's a classification, for example, we can also display the accuracy or the F1 score, all the metrics you want to have. You just need to define that in your Python code and then to be able to display that in the TensorBoard. The last thing I wanted to share with you is regarding the model deployment. So for the model deployment, you can see one slide here on AWS. So in AWS, we have one service which is SageMaker, specific for training deep learning models. So the SageMaker or also machine learning model as well. We need to put our data in S3 bucket, then we need to define our notebook to choose the instance that will be from here for the training for the training process, for the training, and this is SageMaker training instance. We can find, for example, this one, P3 16x large, and this depends on the number of GPU and on the power of the GPU. We will need to pay a specific amount. And then we have also the ECR, which is the Elastic Center Registry, I think. And this is also important to upload the Docker images, for example, and these Docker images will call the SageMaker model to perform the inference. So what is not mentioned here is the checkpoint. Is very important when we train our model, then to save our model in a specific checkpoint endpoint, for example, of AWS, and then using this endpoint, you can, using a Docker image or Python code, we can use, for example, Lambda services to activate that in our Ruby or something like that. So this is for the deployment step. For sure, we can discuss about that hours. Then we have also the last thing I wanted to share with you in this video is regarding the how to split the data and what are currently the different methods to split the data. So it's always very important to split in train, validation, and test. The train is always used to train the machine to the largest portion of the dataset, helps the model learn patterns or relationship in the data. The validation is used to tune hyperparameters and evaluate model performance during training, prevents also overfitting by providing feedback on model performance. The test data is used to evaluate the final performance and generalization ability of the trained model. Should be unseen by the model during training validation. This key is like very important, specifically in the medical area, which is very crucial to use the test only at the end of the process to make sure the data is completely clean. Provide also an unbiased estimate of the model's performance on new unseen data. So the first method we have is the hard out method, meaning we have the dataset, we just split our dataset between 80% for the training and 20% for the testing. We have also the k-fold cross-validation, meaning we take our dataset, we split that in, for example, let's say three buckets, three sub dataset. We have two that we are going to use for the training and one for the test. This is the first model. Then we just invert that. We take this one and this one for the training and this one for the test. And at the end, we take this one and this one for the train and this one for the test, for example. So then we will have three different models and we will have three different accuracy. So the last result for that will be the average of the accuracy from the k-fold cross-validation. This allows us to get an observation on more data and to make sure that the results that we have evaluated using the test is not because we use this specific test, because you also use an average of other portion of the dataset. So this is statistics, okay? We just need to make sure that our data, our result is currently consistent on all the area of the dataset. That's why we use this kind of replacement step of training and testing in order to get this average as precise as possible. The last one is leave one out cross-validation, meaning we take all the samples. This is the same idea of the k-fold cross-validation, but instead of cutting the in-fold cross-validation in part of the dataset, we take all the samples and we just leave one, and then we train on all the samples, we predict on one, then we replace it. We use this one also in the training and we take another one for the test and so on, and then we get the average of the validation of the accuracy for all of them, and this mean accuracy will be our last result. So that's it for this video. Thank you for listening me. Share this video on LinkedIn, on YouTube, and continue going forward for 3D vision and applied machine learning.